Welcome to today's online class, children. Today's topic is heating effect of current. Okay, what is it? See, whenever a current is passed through a conductor means definitely it will have some resistance, right? Okay, whenever a current is passed through a conductor for some time, then after some time what happens? It becomes very hot. Okay, it becomes hot after some time. Okay, this effect is what is called heating effect of current. Whenever you are passing a current through a conductor, okay, it becomes hot after some time. This effect is what is called heating effect of current, or it is also called Joule's heating effect. It is also called Joule's heating effect. Okay, right. So what is it? What is heating effect of? When you pass a current through a conductor, it becomes hot. For some time, it becomes hot. Definitely. Okay. So this effect is what is called heating effect of current. Okay. So this actually becomes a working principle of various electrical appliances we use in day-to-day life. Various electrical appliances, the principle is nothing but heating effect of current. Okay, can you guess what are they? See, right from electric bulb, okay, electric heater, okay, geyser, immersion coil, iron box, okay, so etc. electric furnace, okay, whatever. Therefore, these are all the appliances, and so many, okay, and even fuse, electric fuse, okay, they work on the principle of heating effect of current. Okay, right. Now, knowing this, what is heating effect? So now let us go to what is the cause of heating effect of current. Cause. Now we are going to see what is the cause of heating effect of current. Okay. Cause of heating effect. Okay, so what is the cause? See, when you take a conductor having certain resistance, okay, and you are actually sending and you are applying some potential difference, okay. When you are applying some potential difference, okay, you know very well that, okay, there are it is a conductor, therefore so many number of free electrons will be there. So what happens? The electrons will be drifted towards the positive end of the electrode, okay, the positive end of the conductor. Positive end of the conductor is A, because A is connected to positive, right? Therefore, what is the current? Therefore, current will be flowing. Therefore, the current will be flowing in the opposite direction. You know very well, when you are applying potential difference across the conductor, ends of the conductor, an electric field is set up inside the conductor. Electric field is set up inside the conductor. Inside the conductor, there will be electric field. Because of that electric field, electrons will be drifted, okay, to the positive end of the conductor, okay. And you know very well, it has large number of free electrons. All the free electrons will be drifted towards A. Okay, that time they undergo lots and lots of collision, because the electrons are getting accelerated because of what is that electric field, applied electric field. Therefore, what they do, they will be drifted towards A, towards the positive end. So as they do, they undergo so many collisions. Okay, as they undergo collision, all its energy, because once they are accelerated, by the electric field, okay, and therefore, and they are getting some kinetic energy, extra kinetic energy, and this energy, actually all the energy, okay, and they are getting some this kinetic energy they are getting in addition to some thermal energy. These and all we have already seen. Okay, the electrons are getting some energy, that is already they have some thermal energy. In addition to that, they are getting some extra energy. These accelerated electrons, as they collide with the ions or atoms on the path, what they do, they transfer all their kinetic energy to the atoms or ions with which they collide. Okay, so now ions and atoms are getting more energy, more energy, and as they get energy, what they'll do, they are actually vibrating. Okay, so because they are having some thermal energy, because of that they won't be at rest, they will be vibrating with certain amplitude. But now because of collision, they are getting more energy from the electrons. Okay, and because of that, what they'll do, they start vibrating. Okay, the amplitude of thermal vibration or everything, it will vibrating with a larger amplitude of vibration will increase. Therefore, the amplitude of vibration of the thermal lattice increases, and consequently, what will happen? The temperature of the conductor rises. Okay, every atom is getting more kinetic energy. Because of the more energy, because of that, they vibrate with what is a larger amplitude, and hence, what is that? The consequently, what is the temperature of the conductor rises. Okay, therefore, what is it? Because of flow of current, because the electrons are moving in the particular direction only when they are subjected to the electric field. Therefore, when the current passes through the conductor, only what is that? It gets heated. It gets heated. Why? Only then they will undergo lots and lots of electrons will be drifted. They will undergo collision. Energy will be transferred to ions. Ions will start vibrating with larger amplitude, and hence heat will be produced. Okay, therefore, the electrical energy whichever is supplied by the source, here battery is there now, that electrical energy is you know very well, energy can neither be created nor be destroyed. Therefore, this electrical energy supplied by what? Supplied by the source. Yes, now, okay, is converted. Okay, converted to which energy? Heat energy. Are you following? So that is the cause of heating effect. Okay, now whatever electric energy you are supplying to pass a current through a conductor, partially that energy will be converted into what is called the heat energy. Okay, so now we are going to see the expression for heat. What is it? Heat produced in a conductor by the electric current. Therefore, now we are going for heat produced by electric current. What is the expression? We are going to find it. What is the expression for heat that is produced by the electric current? Okay, now the same thing. What is that? There is a, okay, once again, conductor. Okay, the conductor or having a resistance that is R. Here is a conductor and it is having a resistance that is R. Okay, this is R. Okay, the conductor having a resistance R. Okay, and I am applying a potential that is V. Because of that, it sends a current that is I. Okay, and the two ends, let it be A and B. Therefore, the potential difference across R will be V only, no? Potential difference across R is V. Is it clear? Right. Therefore, now what you are going to do here is, therefore, now see here, next one. See here, what is that? Consider, see, AB is a conductor. And AB is a conductor of resistance that is R, and let V be the potential difference. I is a current, everything is known, right? And I am sending the current for time T. I am sending the current for time that is T. Is it clear? Therefore, what is, see, the electrons will be moving from this side to this side, that is B to A. Therefore, see how many number of electrons are, let n be the number of electrons. See, I am setting the current for a time t. T is the time for which current is flown. Current is flowing through AB. Are you following? Therefore, now it is very, very important. You know that let there be n number of electrons. N electrons are, okay, they are moving from B to A. N number of electrons are moving from B to A. Therefore, how many charges are moving from B to A? That is minus Ne. Are you following? Okay, it is minus Ne. So, number of electrons, number of charges. Now, see, number of electrons moving is n. Therefore, how many charges are moving from B to A? That is equal to minus Ne. Hope you are following. E is the electronic charge. N is the number of electrons moving from B to A in a time t. In time t. Are you following? So, how many charges are moving from B to A? That is minus Ne. That can be considered as, therefore, you can say, therefore, total charge, okay, flowing from A to B. From A to B in time t. In time t, what should that be? Let it be Q. That is equal to plus Ne. Are you following? See, minus Ne is flowing from B to A. That can be considered as flow of plus Ne charge that is flowing from A to B. Both are same. Minus Ne electrons are moving. Minus Ne charge is moving from B to A is equivalent to, what is that? Plus Ne of charge that is flowing from A to B. Are you following? Is it clear? So, I am giving with respect to positive charge. Therefore, total charge flowing from A to B in a time t that is equal to, what is that? Q that is equal to Ne. Okay. And that can be, that is nothing but I into T. I into T. Are you following? Therefore, you can say, why? Because Q, therefore, Q that is equal to I into T. Q is equal to I into T. This is the, what is that? Charge that is flowing from A to B. Right. Okay. Now, I think you know what is the definition of potential difference. See, what is the potential difference between A and B? Between 2 points. Potential difference between any 2 points. Okay, in a circuit, it is the amount, what is that? It is the amount of work done in moving a unit positive charge from one point to another. Are you following? Therefore, now I can say that by definition, what is the potential difference? It is nothing but potential. What is the potential difference between A and B is nothing but V, na? Therefore, the potential difference between, okay, A and B. A and B, that is nothing but V, na? That is, okay, A and B is nothing but V. Okay, that is nothing but the work done by definition. It is by definition. Okay, just now I have given the definition. Now you know that one. Okay, we have seen. Therefore, work done in carrying, what is that? Unit charge. Unit positive charge. Unit charge means was unit positive charge from A to B. From A to B. Okay. Therefore, what is that? Work done V that is equal to work done, okay, per charge Q. Are you following? Are you following? Q is the amount of charge that is flowing in a time t. Therefore, what is the potential difference? Work done per charge. Are you following? Therefore, now what will be the work done? Therefore, work done W that is equal to V into Q. These things are not new. We have seen everything in electrostatics, right? That is nothing but, now Q is equal to IT now. Therefore, VIT, that is equal to VIT. Are you following? And that is nothing. V is equal to, by Ohm's law, IR into IT. Okay. And that is nothing but I squared RT. I squared RT. Are you following, children? Therefore, this work done is what is called the electric work done. It is nothing but, therefore, this is the electric work done. Work done means what is that? There are so many work. It is a electric work done. This electric work done, W, that is nothing but, you can say, okay, and if this electric work done, okay, it appears as heat energy. It appears as heat. Okay. Therefore, this electric work done, okay, if this electric work done, W, appears as heat, then, okay, this work done is appearing as heat, then maximum amount of heat. Why? Full of its electric work done is converted into heat. Then it is a maximum ceiling of the, what is the maximum amount of heat produced in the conductor. Is H, that is equal to heat. That is nothing but the electric work done, and that is nothing but I squared RT. I squared RT, that will be in joules. Okay, if you have to represent in terms of calories, therefore that is I squared, you know how to convert now, divided by 4.18 calories. Are you following? Therefore, now this equation is there, the statement, that is, what is that? H is equal to heat produced, that is equal to I squared RT, and therefore you can say I squared RT. Okay, and this is what is called, the statement itself, it is what is called Joule's law of heating. H is equal to I squared RT. It is what is called Joule's law of heating. Therefore, what actually it states? The heat actually, Joule's law of heating states that the amount of heat produced in a conductor, okay, when a current is passed through it, okay, amount of heat energy produced in a conductor when a current is passed through it is directly proportional to square of the current passing through the conductor, okay, and directly proportional to the resistance of the conductor, and directly proportional to time for which the current is passed. Through the conductor. Are you following, children? Therefore, this is what is called, what is that? Joule's law of heating. This is what is called Joule's law of heating. Okay. Therefore, whatever, it is nothing but work done. Okay. It is the amount of work done in, it is here. It is converted in electric work done, that is nothing but VQ. If that work done fully, it is converted to heat energy, maximum amount of heat energy produced. Actually, heat energy produced, H is equal to I squared RT, means it is a maximum amount of heat that can be produced in the conductor is what is called I squared RT. That is nothing but Joule's law of heating. Hope you are following, children. Okay, right. Next one. Next is, we will see what is electric energy. See what is electric energy. What is electric energy? We are going to see. Say, electric energy, every circuit, electric circuit actually consumes definitely some energy. Okay, and therefore how to define that electric energy? That is what is called electric energy is consumed by any electric circuit when it is put into use. Therefore, now I am going to define what is electric energy. The electric energy, that is say, of a circuit are consumed by a consumed in a circuit. Okay, it is how to define. Now I am going to see it is defined as the total work done, or energy supplied, total work done or energy supplied by the source. By the source means what is that? Source of EMF, battery. By the source for what? In maintaining the current in the circuit for a given time. Is called the electric energy that is consumed in the circuit. Are you following? Therefore, once again I repeat, what is that? It is electric energy. What is electric energy? It is the total work done, electric work done. Work done means it is electric work done. Now you know, okay? So, total electric work done or energy supplied, either it is work done or energy supplied by the source in maintaining the current in a electric circuit for a given time is what is called the electric energy consumed by the circuit. Okay, therefore W, electric work done. Okay, that is nothing but VIT. Just now we have seen electric work done is nothing but VIT. Okay, and that is nothing but I squared RT. Correct? And that I want to write. See, here I have written in terms of V and I. Another one I have written in terms of I and R. Now I want to express in terms of V and R. Therefore, what is I squared? I squared is equal to V squared by R. V by R, na? I is equal to V by R into RT. Therefore, that is nothing but V squared by R into T. Are you following? And that is nothing but the work done or what is the electric energy that is consumed by a circuit. Okay. For what? In maintaining the current in the circuit for a given time. Okay, therefore you can cite, therefore what is W? That is equal to U, electric energy, that is equal to VIT, that is equal to I squared RT, that is equal to V squared by R into T. These expressions are not new to you. You would have studied in your 10th standard, children. I am sure this is there. Okay, right. So this is about electric energy. Therefore, what is the SI unit of electric energy? This is also SI unit of electric energy is nothing but joules, na? That is nothing but joules. Okay, right. Okay, therefore this you know. Now let us go for electric power. What is electric power? See, what do you mean by electric power? Here, see that it is, electric energy is the work done or energy supplied by the source in maintaining the current in the circuit. Okay, but now what is electric power? Electric power is nothing but the rate at which the work is done or energy supplied, rate at which the work is done or the rate of work done. The rate of work done or energy supplied by the source in maintaining the current in the circuit is called as, okay, the electric power of the circuit. Electric power of the circuit. Are you following? Now I am defining electric power of the circuit. Okay, what is that? It is defined as a rate at which the work is done or energy supplied by the source for what? In maintaining the current in the circuit. In maintaining the current in the circuit is what is called the electric power of the circuit. Now I am giving electric power of the circuit. Are you following? Right. Therefore, the electric power of the circuit is associated with the energy supplied by the source. Rate at which the energy is supplied by the source. Okay. That for what? In maintaining the current in the circuit is what is called electric power of the circuit. Therefore, how to express? Okay. Therefore, electric power. Therefore, the electric power is denoted by capital P. The power is nothing but rate at which the work is done. Therefore, work done divided by time, or the rate at which the energy is supplied, or it is U by T. Are you following? Therefore, you can say, therefore, just now we have seen what is W, work done, and what is U. Therefore, now what is PP? That is equal to VI by T na? That is, what is that? W is equal to VIT. Therefore, VIT by T means it is VI. That is nothing but I squared R. And that is nothing but V squared by R. So, this is, what is that? The expression for the electric power of this circuit here, right? Okay. Therefore, what is the unit here? SI unit of power. SI unit of power. That is nothing but, okay, what is that? It is work done per time. Is it? Therefore, work done per time. Therefore, that is nothing but what? Joules per work done divided by joules per second. Okay, and that is nothing but joules per second is what is called watt. Watt, capital W. That is why here I have done work done, work done. Capital W is nothing but symbol for watt. Okay, right. Now, how to define? Now, I am going to define 1 watt. What is that? Define 1 watt. What is your power? Power that is equal to VI. Okay. When V that is equal to 1 volt and I that is equal to 1 ampere. Okay. Then P that is equal to 1 watt na? P is equal to 1 watt. Therefore, you can say the power of an electric circuit. Are you following? Power of a electric circuit. We will be seeing one more thing. Power of a device. Here it is power of a electric circuit. Okay. Is said to be 1 watt. Power of an electric circuit is said to be 1 watt. Okay. If 1 ampere of current flows through it against the potential difference of 1 volt. Against the potential difference of 1 volt. Are you following, children? So, what is that? Here, power of an electric circuit. So far, we are dealing only with the electric power of a circuit. Okay. Therefore, power of an electric circuit, electric power of a circuit, okay, is said to be 1 watt. Okay. If 1 ampere of current flows through it against the potential difference of, what is that? 1 volt. Okay. So, therefore, what are all the bigger unit for power? Kilowatt, megawatt, etc., etc. Okay. Right. Now, what is a commercial unit of power? Commercial unit of power is, okay, that is horsepower. That is HP, horsepower. How it is related to the SI unit? That is watt. Therefore, 1 horsepower is equal to 746 watt. 1 horsepower that is equal to 746 watt. Is it clear? Hope you're following, children. Okay, right. Now, therefore, okay, you know what is the commercial unit of power. Now, what is the commercial unit of energy? Electrical energy, commercial unit of electric energy. What we are? Power. What is the power, energy, everything? We are dealing only with electric power and electric energy. See, last year we have studied mechanical energy, mechanical power. Here we are dealing with electric power, electric energy. Okay, therefore, what is that? It is nothing but, okay, commercial unit is kilowatt hour. It is, what is that? It is kilowatt hour. That is, symbol is this, kilowatt hour. Okay, therefore, is it clear? Therefore, now, okay, this, it is a commercial unit of electrical energy is kilowatt hour, right? Now, one more thing I want to tell you. See, I told you, know, power of once again, because I should have done that itself. Anyhow, power of, see, so far we have seen power of electric circuit. Now we are going for power of, I'll come back to kilowatt hour afterwards because one more thing is required here. Okay, power of electric device, electric appliance or electric device, electrical device. What do you mean by that? You see, so far we dealt with power of an electric circuit. Power of electric circuit is the amount of work done, rate at which the work is done or energy is supplied by the source. For what? In maintaining the current in the circuit. So, power of electric circuit means is associated with the source. But what is the power of electric device? Okay, every electrical device, electrical appliance, okay, it is rated with some power. I think you know. See, for example, if you have a bulb means 100 watt bulb, okay, and 1000 watt bulb, okay, and heater, if immersion coil means 2000 watt immersion coil, the rating will be, it is what is called rating. It will be there, rating will be there for electric, what is that? It is, for example, if you have an immersion coil or iron box, okay, iron box, it may, it would have written there in the appliance itself, 1500 watt 220 volt. Like that it is written. It would have written like that. Okay. So what is that? That electric, what is that iron box? Okay. It works under, what is a 220 volt and its power is 1500 watt. What do you mean by the power of an electric device? See, an electric iron box is having, what is that? The power of 1500 watt at 220 volt. Okay. Therefore, what do you mean by that? See, it means that when you are using it, it is 1500 watt mone kya aata joules per second na? 1500 joules, so you know 1500 joules per second is only what is called watt, correct? Joule per second is only watt. Therefore, it is 1500 joule per second. What do you mean by it? When an electric appliance, here I told you it is a iron box. When you are using an iron box for, what is that? How much energy it is consuming. Okay, it consumes 1500 watt iron box is used. Then, how much energy it consumes? Electric energy it consumes. It consumes 1500 joules of energy in 1 second. Every second it is using, it is consuming. Okay, when it is put into use, okay, it consumes electric energy. At what rate? It consumes 1500 joules of energy in every second. In every second. Are you following? Like that, 100 watt bulb. 100 watt bulb, what actually it means? It consumes 100 joules of energy in every second. Are you following? So, okay, therefore, power of an electric device. Okay, therefore, what is that? It is given, power of electric device means it is the rate at which the energy is consumed by the device. Power of electric device means what is that? It is a rate at which the energy is consumed by the device is called as power of electric device. Power of electric circuit means rate at which the energy is supplied by the source in maintaining the current in the circuit. But power of electric device, any device, when it is put into use, what is the power of a device? It is the rate at which the energy is consumed by the device. Are you following? Therefore, now I want you to define. For example, see, you have to understand. Okay, therefore, it is a power of electric device means what is it? Define. Now, define 1 watt with respect to power of a device. With respect to power of a device. Okay, therefore, what is that? 1 watt means what is a 1 joule per second now? Okay, therefore, you can say power of a device is said to be 1 watt when if it consumes power of a device, electric power of a device, it is electric power, okay. Okay, power of a device is said to be 1 watt if it consumes 1 joule of energy in 1 second, correct? 1 joule of consumes, it consumes 1 joule of energy in 1 second, okay, when it is in use, when you are using. Okay, therefore, power of a electric device is said to be 1 watt if it consumes 1 joule of energy in 1 second when it is put into use. Okay, so this is about what is that? So you know that you can define power with respect to a source also and with respect to the device, electric device also. Source means rate at which the energy is supplied. With respect to device means the rate at which energy is consumed. Energy is consumed. Are you following, children? So this is how you have to differentiate. Right. Therefore, now I am going to give you what is the kilowatt hour. You come back to kilowatt hour now. Okay. Therefore, what is kilowatt hour? See, what commercial unit. Now come back to the commercial unit of energy is 1 kilowatt hour. Just now therefore, now how to define kilowatt hours? You know that energy, okay, you know the power, okay, let me, power that is equal to, what is power? Power that is equal to work done, rate at which the work done or rate at which the energy is supplied, correct? Therefore, what is electric energy? Energy that is equal to P into T. P into T. Are you following? Therefore, now I am going to give the commercial unit of what is that energy, electric energy. Therefore, see, when will it be equal to 1 kilowatt hour? When P that is equal to 1 kilowatt, power of the appliance is equal to 1 kilowatt, that is equal to 1000 watt. Okay, and when it is put into use for 1 hour, when it is put into use for 1 hour, then energy consumed U that is equal to P into T, that is nothing but 1 kilowatt hour, correct? Energy consumed. Okay, therefore, how to define now? I am going to define 1 kilowatt hour. What is 1 kilowatt hour? See, 1 kilowatt hour is also called as 1 unit. That is very important. 1 unit. What is 1 unit of energy? 1 unit of energy means 1 kilowatt hour of energy. Okay, so in our electric meter, no, at our house, it measures the whatever electric energy we are consuming. It is measuring only in terms of unit, correct? 1 unit is nothing but 1 kilowatt hour. Okay, therefore, how to define 1 kilowatt hour? See, if, okay, if an electric device of 1 kilowatt of power, 1 kilowatt is used for 1 hour, okay, then what is that? The energy consumed by the appliance is 1 kilowatt hour. Okay, therefore, how to define? Once again, see, 1 kilowatt an hour is the total energy consumed when an electric appliance of power 1 kilowatt, okay, and is used for 1 hour, or it works for 1 hour. Are you following? Define 1 kilowatt hour. 1 kilowatt hour is nothing but 1 unit of electric energy. Okay, how to define? 1 kilowatt hour is the total electric energy consumed when an electric appliance of power 1 kilowatt and is used for 1 hour. Okay, therefore that is what is called 1 kilowatt hour. Define 1 kilowatt hour once again. See, you have to take the notes properly. I am not going to write it. Okay, so you know very well. You have to take the notes. I am repeating so many times as I do in the class. So, thus 1 kilowatt hour is the total electric energy consumed when an electrical appliance of, okay, power 1 kilowatt works for 1 hour, are used for 1 hour. Okay, so this is about 1 kilowatt hour. How to convert it into joule? Therefore, actually SI unit is joule, but commercial unit of energy is kilowatt hour. So this also you know very well. This is not new to you. Therefore, that is nothing but 1 kilowatt ka kya hai? 1000 watt karo. Why kilowatt? See, you know that watt second is nothing but joule. Correct? Joule per second is what? Watt second is joule. So 1 kilowatt hour ka kya karna hai? Aapko watt second convert karna hai. Therefore, kilowatt is, what is that? 1000 watt, and hour you convert it into second. Therefore, it is nothing but 3600 second. Are you following? Therefore, that is nothing but 3.6 into 10 power 6 joule. 3.6 into 10 power 6 joule. Are you following? Therefore, 1 kilowatt hour is equal to 3.6 into 10 power 6 joule. Are you following, children? Okay. Now, one small problem with that. See, here I'll give you a bulb of, see, very simple 10th standard problem. Anyhow, I'm giving, okay, a bulb of 100 watt, okay, is operating for 6 hours. Very common problem that you would have done in your 10th standard. Hours a day. Okay, find the units of energy. The units of energy consumed in 7 days. In 7 days. For, okay, therefore, what is the energy consumed? Can you give me energy consumed? Energy, what is given first? Okay, and the first, that is very important, no? I'm telling every time, see, what is that? What are all the things given? You tell me, what is the power, bulb of power, P, that is equal to 100 watt. And unit made, what is that? It is asked for units of energy, kilowatt hour, okay? Therefore, you convert it into kilowatt directly, therefore, it is 1 by 10 kilowatt, na? It is 1 by 10 kilowatt divided by 1000, na? Therefore, 1 by, are you following? Okay, into 10 power minus 3 kilowatt, na? Okay, therefore, it is 1 by 10 kilowatt. Okay, now, how many hours? 6 hours. Okay, therefore, how many days? 7 days. Therefore, per day 6 hours. Therefore, what is the time here? Time here is, okay, 6 into 7 hours per day 6 hours. How many days? 7. Therefore 6 into 7 hours. Are you following, children? Therefore, now what is your energy consumed? Energy consumed. Okay, E, that is nothing but P into T na. Energy consumed, you know. See, because E is, we are keeping in, okay, U, that is equal to P into T. Okay, therefore, that is P, what is that? 1 by 10 into 6 into 7. Okay, and it is kilowatt, and this is 6 into 7 is in hour, and I think that is nothing but 42 by 10, 4.2 kilowatt hour. That is nothing but 4.2 units of energy. Are you following? Is it clear? So